Hello and welcome back to another Did You Get It? This one is for lesson 2.8, which is really just a great culmination of all of Unit 2. This video will also be a really good support for your Unit 2 project. So let's go ahead and head to page 243 in your workbook, and you'll see the Did You Get It down at the bottom. It says the table below shows the number of women serving in the U.S. House of Representatives for selected years from 1980 to 2008. Find both a linear and an exponential model for the data. Write the correlation coefficients, then decide which model you think is a better fit for the data. Round coefficients so that they have 5 total digits. So, a few things to remember before we get started in Desmos. That when we're dealing with years as our input, we never use the years because they're too big for the scaling. So we always find a base year to start from. And because 1980 is a nice even number, and that's the first data piece that we have, we're going to use that as our base year. So that is going to be considered 0. So we would find that, for instance, 1996, if you take 1996 and subtract the base year of 1980, you would see that it's 16 years after 1980. And that's why this says 16. So sometimes you're going to have to create that X column yourself using the base year. So this is going to go into our X1 or X2, whatever your table says. Then the women in the House of Representatives is going to be your Y1. Okay, when we get there, what we're going to do is we're going to create, we're going to put a table in Desmos with this data. We're going to look at it on the graph like we always do as a good investigative math researcher. And then we're going to do 2 models. They want us to do a linear model and an exponential. So let's just review how to do a linear model. A linear model, you're going to take your Y1 and you're going to use a tilde because remember, we're modeling, we're fitting a model to the data. And then it's going to be M, and then X1 is where my X data is, R plus B. And then it will give us the correlation coefficient that we need to decide which one is a better fit. And then the exponential model is using Y1 again in the tilde, but it's going to be A times B to the X1. X1 needs to be in the exponent. Remember, to get it to go into the exponent, it's your shift key and the number 6 key. And then you also, when it's the exponential, you also have to make a check in that checkbox that says log mode. Okay, so let's just go ahead and take a minute and get your Desmos open. And we're going to go there now. And you can see that you'll want to make sure that you're logged into Desmos and that you save this as your, I saved mine as my lesson 2.8, Did You Get It? And this is great help again for the project for Unit 2. So if you want to make a note for yourself with words, you're going to go ahead and click on the note, and then you can type in words here. And then I created my table, so go ahead and do that. And then I would like to see what this data looks like on the graph. So I'm going to hit my magnifying glass, and there it is. Sometimes you have to touch the magnifying glass twice. Now, I'd say if we look at just the data right in here where my mouse is, it looks very linear. But when we add the data down here, the first 3 data points, it kind of looks like it might be a good exponential. So we're going to do both models. So again, I'm going to make a note that this is my linear model below. And then I'm going to do Y1 with the tilde. Remember the tilde, you can do it with the shift key and your key to the left of the 1, or you can do the menu down below and you can find using this A to the B button will us, or wait, I'm sorry, that's not there. Your tilde is in this menu right here. So your shift menu, and it's right here where my mouse is if you have to use the menu. Okay, so back to the linear model. And then X1 plus B. So there is my model for my data. So it looks like the the slope is 2.229, so 2.23 is what I would use. And the y-intercept is 14.9167. I'm going to write this on my paper, and we'll come back to that in a moment. And we're also going to note the r squared, because that's our correlation coefficient. So that's 0.9682. And then I'm going to scroll down, and I'm going to go ahead and make the next row. I'm going to make that a note, and I'm going to say exponential below. And that's going to be y1 in the tilde, and then a, b, to the x1. And then don't forget to click the log mode box, or you will not have the r squared. So if you don't have the log mode box checked, you won't see the r squared is there, but it's not correct. So you want to make sure that you're doing the log mode box. So you can see that our parameters are, the y-intercept is 19.1732. And then our growth multiplier is 1.05562. And the r squared is, the correlation coefficient is 0.941. And what's really cool is you can see that they fit the graph, the equation model right on the graph. So just looking at the r squared, it looks like the r squared, the correlation coefficient, is stronger for the linear. It's closer to 1. So let's go ahead and I'll show you how we wrote the models on our paper here. So I wrote the linear model here, and then the exponential model here. And it looks like, because the r squared is bigger, that we're going to choose the linear, because the r squared is bigger. Then the Did You Get It number 2 on page 245 is referencing this. It says, use each of the models you found to predict the number of women in the House of Representatives in 2016 and 2019. Then look up the actual numbers and describe if that changes your opinion on which model is better. So we're going to do 2016. Let's make a little table here. So we've got 2016 and 2019. And then we've got actual. And then we've got the model, the linear model, and then we've got the exponential model. Okay. So let's go back to our two models. And we have to remember that 2016, it looks like, remember when we did our base year, it was 1980. So 2016 minus 1980 would be x equals 36. And then 2019 minus 1980 would be x equals 39. You can see my calculation there on the screen here. Okay, and so I'm going to do x equals 36. And you can see I can just click on both graphs, and I can see my linear at in 2016, my linear would be about 95 representatives. And if I go and click on my purple graph and it intersects x equals 36, it says my exponential there should have been 134 to 135, depending on the rounding. And then let's go ahead and graph. I'm down, and this is just down over on my commands. I'm going to type x equals 39. And then I can do the same thing. I can click on my graph. So my linear says approximately 101 to 102. And my exponential says approximately 58 to 158 to 159. And now I'm going to just go search in my Google search, and I'm going to say number of women in the U.S. House of Representatives in 2016. See, this should show us here. So in the U.S. House, there were 84 actual in 2016. And then I'm going to change that in my search to 2019. And there were 101 in the U.S. House. And so I'm going to go back to my paper so that we can discuss. So it looks like the linear model was the best for 2016. It wasn't great though. We definitely over predicted here. But the 2019 model, we were spot on 101 on the linear. So it looks like the linear was definitely the best model for both situations. So this hopefully will help you with your Unit 2 project. Catch me back for some more videos.